Hey guys, thanks for coming to the OLED Wave channel. We read the latest speech and NLP works, including the archived papers. But today, we're going to be reading a very famous paper. The paper is the actual technology behind the famous ChatGPT API by OpenAI. And I think the paper is referred by OpenAI as InstructGPT. The title is Training Language Model to Follow Instruction with Human Feedback. And this is a long version of the paper sharing. It's going to take maybe 30 minutes to 1 hour. And we do have a short version, which is just 3 minutes of the overview of this work. You're okay if you want to just see the short version, that's okay, and we will start. First of all, I think all of you have played with ChatGPT. The result, I think, is very surprising, or what kind of feelings you have to lots of people. But what's the technology behind it, and how does it work? This is our channel is focusing on. We focus on the paper readings, and it happens that OpenAI actually published their work back in March last year. But I guess is that the system is way better than it was in March 2022. It's almost 1 year from now. But I think that the technology behind it is roughly the same. I would say. I think also this is important to understand not only how it works, but what did these authors from OpenAI think, and how did they come up with the InstructGPT, or AKA reinforcement learning human feedback stuff. And the most important thing you want to think about also by yourself is that how do you align the large language model with human intention or feedback? Okay, let's start. The abstract wise, I think I would say you definitely, if you are really interested in this work, you would probably will try to read the famous GPT-3 work. GPT-3 come up with a model with 175 billion parameters. I want to increase the size a bit. Yeah. But in the GPT mentioned in this paper, which is InstructGPT, they talked about even if you have just a 1.3 billion parameters, the model performance is roughly okay compared to the super large model. And also, the most important thing this paper delivered was how to fine tune with human feedback. And also, this is for aligning the super large language model with human intent. Okay. Introduction wise, since I'm a more like a speech people, I'm not NLP people. Those people are not very familiar to me. But definitely those are good papers. You should read it if you want to explore ChatGPT 3. ChatGPT. I think they say this is the take-home message. They say that aligning language model to human intent is important, and that the technology they're focusing on, or the path they took, was fine-tuning. And this is how it works. I think you want to see this figure. Let me see if I can explain this clearly. This is the core part of this paper, or the procedure, how they train the model, okay? Mm-hmm. And the whole training would be divided into 3 steps. Step 1 is fine-tuning. For those of you who do not know what is fine-tuning, you probably want to read the paper of BERT, B-E-R-T. Okay. So it's about when you first come up with a pre-trained model, and then on a specific task, you got a lot of supervised or labeled data of that task, and you just use those data to update your model. So you have the Y and X input and output. You do not change all the parameters drastically. This is why they are called not called a tune, but called a fine tune. Okay. How did they fine tune? Generally speaking, they first hire 40 human beings. They call them laborers. And they give a task to laborer. And the laborer is supposed to be writing prompts and the corresponding responses. Okay. For example, explain the moon landing to a 6-year-old. Okay. Then the laborer start to write these things. You can see that these prompts and the responses are of high quality. Mm-hmm. What do I mean by high quality? It's well controlled compared to the web responses from the internet by their OpenAI customers. Some people just randomly giving them reply responses, right? And the prompts, some people give the prompts are ambiguous or not very good. And this time with a high quality prompt and response, and for each different task, they were able to fine tune the original pre-trained model or GPT-3 model in a supervised learning style. And the model they come up with is called a supervised fine-tuning model, or SFT. Okay, that's the first step. Okay, and the second step, they try to train a reward model. It's called RM. How to do it? Now this time, it is still supervised. The labelers are still being asked to perform tasks. But this time, the labeler does not have to write prompts and responses. They would use the SFT model they train in the first step, and try to use that model to generate several responses. Okay, you can see they're sampled, so the model can, giving the same prompt, the model can keep generating responses. Okay, can have 1,000, 10,000, but they would just generate, I think, 4 to 9 responses, and if for each 2 of them, okay, responses, each 2 of them, a labeler was asked to rank these 2 responses. Which one does he or she prefer? Mm-hmm. And after this, so you can see that they collect the labeled data of preference or human intent. It's not just a response, but how people would score these responses. Okay. Then they use these data to train a reward model. Okay, the reward model is not the super fine-tuned model, but definitely reward model is trained on the output of the super fine-tuned model and the human responses, or human labels, or human scores. So it comes to the final step, step 3. So in the step 3, the key is they want to train a policy. So you can see that eventually they are not supposed to be using the exact SFT model to generate the output. Otherwise, there's no point of training this reward model right here. But instead, they want to wiggle or juggle the SFT model a little bit so that this SFT model's output would be receiving better score by the reward model. You can see here. So I think I explained that fairly clearly. If you're still not getting it, let me say it in a different way. So given a new prompt, and then they utilize a algorithm called the PPO. Just forget about what the terminologies. It's just an algorithm. It will generate the output. This is the model they're supposed to learn, or the policy model. Policy model. The specific model they're using is PPO algorithm. Okay. Mm-hmm. The policy model is right here, and it would generate or pick up the best, or the most likely the model, the most likely response the model would think that would receive a high score by the subsequent reward model. Is that clear? And you can see, if you're familiar with the backpropagation algorithm, you can see, because this is, the RK is the rewarded result, right? Based on this result, the errors can be backprop all the way to the response, okay? So this is, and they can either choose to update the what do you call that, RM? No, they didn't update the RM, I think. Well, instead, they just try to update the PPO, so they are able to learn their PPO model or the policy model. And after this, so you can see that their system is well trained or trained. And then you can see that, and also mentioned that they can also, after the step 3, then go to step 2, because this time the output would not coming from the SFT, but coming from the policy model or the PPO model's output. Okay. Mm-hmm. You can see these results, philosophically speaking, should be slightly better than the SFT, okay? Because it has been adjusted or supervised, trained by the, or reinforcement learned by the RM, okay? And then they use these improved responses and have some human labelers to rank these again. You can get better RM. Make sense? After you get better RM, they use the better RM right here. So you can see that the backpropagation could get better gradients. And they can again, excuse me, update the PPO model. So the PPO model gets better. So you can see this iterative process can be going on and on till you get something that's satisfactory. But according to the paper, they didn't do this type of iteration a lot. Okay, I think if you're getting what I'm saying, I think this is generally what the paper is about. But I do want to show you or discuss with you the thoughts of the authors from OpenAI, and to see how do they define the problem and gather the tools to solve the problem, and based on the results, how do they analyze the results, and eventually how do they come up conclusions and even future directions. Those are something that we want to learn if we want to be a researcher, okay? And I do benefit a lot from reading their stuff. think they first come up with the conclusion first. Okay, they're saying that definitely the results, instruction GPT, or actually nowadays it's called ChatGPT. Okay, in 2023, it's better than GPT-3, and it shows the truthfulness, improve the truthfulness, and improve the toxicity. Yeah, this is my own opinion. If you ask opinion of the ChatGPT, he would not reply you. You can see that ChatGPT never comment on thing or compare thing. If you ask which one do you think is better, A or B, he will just refuse you to do this. But I think they just turn off that function for general public. And also, they also play their instruction GPT on the public benchmarks. Then of course the results wasn't very. They didn't do better than this other algorithm, which used the public benchmark to fine tune. But they were saying that they can minimize the performance regression, which means the model has some capability of generalization. That's what my understanding. And they created a term. I think it's called a alignment text. So it's something that means that I think my understanding is that if you align that with your real human intent, but instead you would be doing not so well on some cases that you haven't seen, some unreal cases, for example, those public benchmarks. They're keeping saying that, and also they're saying that I think they also mentioned that in the appendix, saying that if they want, they can fine tune the model on these public benchmarks to get better results. But that's not these authors' intention. Their intention was to try to align the large language model with human intent, not public benchmarks. Okay. Next stage. Their model generalized to preference of held out labels that didn't produce. Yeah, training. That's details. Also, yeah, they're saying that some popular models like Flan and T0, probably some from Google, maybe from Google. Yeah, I know Flan probably from Google, right? These results didn't perform as good as their InstructGPT, even worse than their SFT baseline. Yeah, also what is important is that they show some promising. They're not saying that it's done. Okay, promising generalization. Because definitely those labelers are working on English, but probably we know that we're playing with ChatGPT in all the languages. For me, I play with Chinese. Chinese is fairly good, I would say. I give a thumb up for Chinese. The interesting thing is, although the GPT-3 model was trained on Chinese with some Chinese text, but the fine-tuning process never had any Chinese text involved in it. So this means that they can not only just generalize to some unseen tasks, but also some new languages or the languages they haven't fine-tuned on. Yeah, they make simple mistakes. I think you all know this. I think today, Yala Kun mentioned that he's saying that asking GPT questions, they're saying that so suppose you hold a piece of paper in this way and you release one hand, which direction the paper will roll into. I think according from text, it's not very clear to me. And also it seems that the ChatGPT thought the paper would roll this direction, not this direction. Simple mistake. Yala-kun mentioned that it's failing to acknowledge some common physical laws. It's not there. Yeah. The second part, I think today, because the key thing was to just read this paper. But I think if you're interested, you can definitely read the citations or references given by these authors. Those are very good one. Especially how to train a model, follow instructions. I think this is interesting to me. And also upward. So alignment and learning from human feedback is not new. There has been lots of work on this. I think if you talk about novelness, there definitely has somebody who has done this before, but nobody has done this in a super large scale and with so many contractors and well-designed experiments. And I think I wouldn't talk about the ethical things I think it's very inappropriate to discuss this other than just focusing on the tech. And also these two are ethical parts, I think. Yes, and these are the three take-home three steps, which are the take-home message. If you didn't get, you can just try to just read it. I don't think I'm gonna read it. Fairly straightforward. So I'm gonna dig into some details. Okay. First of all, data. I think all speech people likes data. Also, NLP people likes data. CV people likes data. How do you organize the data would affect not only your results, but also how do you design your algorithm. Okay. So for those of you who are not familiar with the ChatGPT or OpenAI, I think, according to my knowledge, they do have launched something a year ago. I know it's OpenAI Playground, something like this, a long time ago. So this is how they collect the data. So you can see that the basic or the general prompts, they have tons of these things from the collected prompts from their OpenAI API. Okay. And then this is how they make sure that not so many same prompts were being trained, and then limited a certain speaker from having too many prompts. This is all about avoid the model to be learning a specific person's interest. Okay. And I think this part, I think is details. It's for somebody who are interested in replicating the InstructGPT, but it's definitely understandable. I think these authors, they interchangeably use different words for the same terminology or concept, so this might look confusing to you. I'm trying to use some simple language to explain. Okay. Here's what they ask their labelers or human labelers do. The first thing is to write prompts. They do not only use the prompts from the OpenAI that collects. First of all, they first want the labeler to come up with a task. What task? The tasks are shown in the table number 1 here. You see, task and the use cases are the same thing. The tasks. And you can see that the tasks, most of them are generation. almost 50%. So I think that's, so you can see that they actually fine tune their model. You can imagine or regard their fine tuning or their training was mostly targeting at the generation task. This explains why the ChatGPT works so well for writing some argument, some statement, other than QA. You see, especially the close QA. Close QA means that it's either one of them. Okay, for example, what's the distance from Earth to Moon? That's close QA. But if it's open QA, is that what do you think if I want to get a better life? That's open QA. And then this is also occupied a lot. And this also is explained ChatGPT. A lot of people are using ChatGPT to for life and professional advice. I think I wouldn't say those you should follow those advice, but it's roughly very close to some professional advisor would give you. So the advice that a professional advisor would give you. That's my impression. Okay. Brainstorming, yeah. Brainstorming is, I think, is also roughly similar as an open QA. Okay. For example, how can I make a phone that take over the iPhone? Chat, these type of thing. Okay. That's a task. They want the task that each task to be lots of tasks to be general, so it covers a lot of diversity. Mm-hmm. That means they don't want to be their model to just tackle one case. The second thing is called a few shot. That means that not only to write prompt and response, okay, query or response. It wants to give some an instruction, multiple queries. These two things are actually multiple queries and response supplement or explains this instruction. What does that mean? Let me give you an example. He will say that, can you tell me the most handsome person in Hollywood? That's not enough. And they will give you some example. For example, Tom Cruise, something like this, or handsome person, probably Brad Pitt. Yeah, something. Give some example. So the model would not just generate a response purely based on the prompt, but also based on these examples, or what they call our few shots. Imagine that you have, I think some of you might know the few shot learning. The same thing here, right? The third part is because they have an OpenAI playground. They have collected lots of data, and that they ask. They have a number of use cases. Okay, they ask for certain use cases that has been shown up in the OpenAI's API. They ask laborers, can you come up some prompts that's corresponding to those use cases? Make sense? With these things, okay, you can see all these three things are done by laborers, human laborers, and they produce three different data sets using our fine-tuning procedure. First of all, the data set for their first stage fine-tuning, okay, and the second is there for training their reward model, okay, and third is for training their PPO model or algorithm, okay. An interesting thing is that in the third data set, PPO data set, there's no human label. Does that make sense? Because why? Pause the video and think of why. because in the third stage, no human rating was involved.
Is the reinforcement learning? It's finding the best the
You're
input
right.
from the reward model. Reinforcement learning is that is what is finding the best
Yes, I think you're
policy,
getting
right?
it. They're using the not reinforcement learning, this reward model to score the outputs. They do not need human being in the third stage. Um, for those of you who are online, you can. I think I finished most of it, but for the rest of it, you can wait till tomorrow. I will upload the video. Does that make sense?
Mm-hmm.
Okay. Thanks so much. You can keep
Thank you.
online till the meeting is ended. Um, very. Thank you for following with me. Okay. Really appreciate that.
Thank you. I mean, I should have read the paper before. I didn't. And,
Yeah, that's my point. I want to say a few more things because we still have a few minutes. I created this channel not because I want to make money or something. I want to inspire more people to be interested in speech and NLP research. So because I found lots of people are just interested in methodology. Because if you look at their algorithm, they're super simple. But
mm-hmm.
what is more important is that how do these OpenAI people come up with the idea? How do they assemble these modules into their super interesting model? And how do they come up with the future directions? I would think that uh, if I can inspire someone to be interested in something and get them something better than ChatGPT, I think I would say I have implemented my personal value. All right. Okay. For the more details of these data, I would say you want to check the table number 6. I won't cover it here. Here.
They had like 40 labelers, and do they specify how much data they trained on?
How much? You mean how much hardware they want to?
How much, not hardware? I mean, they had like 40 labelers, and yeah, how much?
How many labelers? Okay,
Yeah,
they
yeah.
have 40. They mentioned 40 in this paper,
Uh,
but that was a year ago, almost a year ago. I imagine that they have way more labelers than they had right now, they had
mm,
before, because you can
okay.
see that the
Mm,
right now the quality of the stuff they
mhm,
generated is beyond people's imagination.
mhm, mhm.
And just FYI, let me first quickly jump to the figure number 5. Here you can see PPO-PTX is the model they proposed in this paper. I draw a line. Okay, I think the score was roughly 4.8. The highest like what is this? Like the RT? It's the like whether you like their response or not. The highest number could be 7. The lowest is 1. So I think nowadays, for me, I would definitely give the ChatGPT results above 6. I don't know how you do, um, but definitely the models uh, is way better than the model they had 1 year ago. That's my impression. So they definitely have either changed their algorithm or hired more contractors, like you mentioned. I guess.
Mhm.
All right. Hope I answered all of the questions. Thank you for coming. I think this
Thank
your
you.
session will be very soon. But I think I will try to wrap up very soon too.
Sure.
The okay. Yeah, the task or user cases, mainly coming from two sources: the labelers and their API. And also, this interesting thing is I didn't fully get it. And they're saying that in each case, or each use case, they ask their labelers to do their best to infer the intent of the user. And that's interesting to me because if you just need a person to write prompts, why do you need to ask the writer to know the intent? Does that mean when you know the intent, you can write the prompts better? Um, and also, yeah, that's the same thing, or implicit intentions. Or if you remember Steve Jobs' presentation, they're talking about the unspoken needs. Okay. Needs. I think this is even deeper than implicit intention. But I think even you ask these labelers, there's no way for you to know how they do on this task. And also, I would put a question mark on the stuff called do their best, because if you check the Upwork where they hire these contractors, the contractors hourly rate is about probably less than $50, maybe even $30 per hour. How do you expect somebody to do their best with it? I mean, if you're creating a price, somebody would probably do their best. But I mean,
Well, they will have like each different labelers have to rank it. I mean, usually labelers, one labeler comes up with, for example, some intent,
they
and
they
then the other labeler has to rank it probably.
you're talking about laborers or laborers. They do have something like this. They would scale their laborers score. They would score the laborers. They have some mechanism,
Mm,
but there's
mm.
no way for them to tell whether the scoring mechanism is good or not. But I would just assume that they have a good way of selecting the labelers. Okay. Yeah, this is how they describe their labeling, how they collect the data. Okay, especially see, I think they just ask, they measure the labeler performance on this axis. But it is very ad hoc to me, because I personally think that it's very hard to control the laborers' quality, especially uh, when they're performing on something like subjective tasks, for example, giving rating to the responses, not just to label these, what word you have said, what's the slot fillings task. Okay, uh, I think they mentioned that despite the task is highly subjective, complexity, they're saying that most time the annotator they agree with each other. But for the sake of argument, agreement is not an indicator of good labeling. Yeah, it could be possible that all the guys in your experiment, or the labelers in your experiment, made the wrong decision, and you have a high correlation. Yes, let's get some hardcore math if you're interested. Um, Here they talk about how they train their model in details. They first start with the GPT-3 model. For those of you who are not familiar with how the model is got trained, you probably want to first start with BERT. I have a sharing in my channel. You just search BERT. I read the BERT paper from a speech researcher's perspective, and GPT-3 is roughly similar to this, I think, but the model is way bigger than BERT. The fine-tuning part is straightforward. Reward modeling, I think, but this is also straightforward. Let me explain the equation to you. Of course, you want to minimize the loss, right? And there's a negative mark. And so you want to maximize the expectation. And this part, K choose 2, that means when you are trying to train their reward modeling, suppose you have K responses given one response, given one prompt. That's possible. Their model can generate multiple responses. And each time, in order for the reward model to give a score, reward function to be calculating, you gotta have to just have 2 responses, not one, not 3, but just 2, because you can only compare 2 things with 2 numbers. And this is how the K choose 2 come from. And this is a normalization. Having this normalization allows the parameter to be consistent when the K changes. Make sense? And what they're saying that they try to randomly sample 2 from these occasional responses for one prompt and mix these 2 responses pair with other responses pair from other prompts into one mini batch. And they found that what? Caused the reward model to overfit. But they didn't explain the details. I didn't. You can correct me if I were wrong. I did not see in their appendix discussing this overfitting procedure. But definitely, you can imagine that this is not good. But also in my common sense or in my gut feeling, this is not a good thing, because you don't want to mix stuff from different prompts into one mini batch. That's strange, especially when you want to use in the reward modeling. Okay, and then what they do is that for each mini batch, they only sample responses from same prompt to form a mini batch. This is how these things come from. That's the number of the sampled pairs in the K responses. I think this is easy to understand, okay? Each time they sampled from the human comparison dataset, they sampled 3 things. X is the prompt. Y sub W is the preferred. The YL is not preferred. And this is a log. And this is the sigma is the reward function. No, it's not reward function. I think it means sigmoid or some activation function. And then this is a reward function. This is a reward function. You can see that they want this to be minimized, but they want the expectation to be maximized, and they want the difference to be as large as possible. Or the liked, unliked, the difference to be as different as possible. The gap between these 2 scores should be big. Makes sense. Okay, everybody would just do the same thing, and I don't think this is new. Next, they are talking about their PPO policy, PPO model, and this is not new because somebody published this work back in 2017. Yeah, everybody can think about this. This is the most fundamental thing you would think of if you want to try the reinforcement learning in the step number 3. Let's see the objective. So you see the phi means the parameters of the model or the PPO model, okay? And they want to maximize 2 things. I think it's not lost. The objectives, so it's like a maximize. You can same thing. Okay, two parts. Let's see the first part. So the X and Y prompt and response are being drawn from the data set of the reinforcement learning data set. So the set number 3. Remember that it's coming from the OpenAI's customers' prompts and the generated response from the PPO model. Okay, there's no human involved. So this is why you didn't see any human preference score or human labels here. Okay, X and Y is the output of their PPO model, and X is the input prompt. Make sense? And so and given this, they fed the X and the Y into their, what do you call that, reward model. Reward model, they have just a trained. You can see that. See the prompt in this. So you can see in this one, the parameter is SIDA. The parameters in the reward model. Okay. So after this, the SIDA is fixed, and for any prompt and the response being fed into this reward model, it's gonna give you a score, and the score is being put here. Okay. So you can see that X is fairly kind of fixed given one prompt. So you want to adjust the Y. Okay, make the Y twiggle a little bit to see whether you can get better reward score. And based on this error would be backprop through the PPO models, the layers, and the gradient stuff. You're able to update the parameters in the PPO model. Then PPO model get better and get better Y, and eventually get higher R sub theta of Y and X. Make sense? And you may wonder that what's the second part of this is. So this part is the KL penalty section. What does that mean? For those of you who are not familiar with KL, just search KL on the Wikipedia. It's take 5 minutes to read it. But the purpose of this is, you can see, they want the policy. You can see this means the policy, the learn policy in this model compared with the learn policy using the supervised fine-tune model, which was learned in the first stage. Okay, they want the two policy to be as close as possible. That makes sense. So if these two things are the same, this is 1, this is 0, there's no penalty. But if their two things are different, you can imagine that this section would lower the overall score. Make sense? And then it considered as a penalty. But having a penalty doesn't mean that you should not have a model different than the supervised fine-tuned model. But if your gain from the reward function or reward model is significantly higher than penalty, you should still update your model. Makes sense? And what is the third term? Third term, in their word, they're saying this the per-train loss. This means it's a factor that controls the learning rates, because they do not want the PPO model to be updated too much or too fast, something like this. They don't want the parameter to be learned too fast. So they add a pre-trained model here. So that means I think this for pre-trained model, everybody knows that they use the master language model, right? So you just still try to retain the capability of the model to output the next word piece token. So they don't want when this thing gets super high, the policy model gets so bad, so good, then it forgot how to predict the next word. So they want the model to retain the capability of predicting the next word by giving some weight to the pre-training. Makes sense? Yeah, you can see that because this is pre-training, there's no Y here. Makes sense? All right, I think I finished the core part of the algorithm. I'm gonna jump onto the evaluation. I would say this evaluation to me is very straightforward. If you look at this one, I'll quickly go over something. Okay, they're testing their model on two different distributions, but this instructor distribution is the new data set they're talking about. Okay, and then you can see that even they train the model on these data sets or these tasks or so-called tasks on this distribution, it still worked well on some distribution it has not seen before compared to the GPT-3 and the GPT prompt. Makes sense? But remember the gamma here? Let me use a blue pen here from now on. If you set the gamma to be 0, that means it's the gamma equal to 0 means it's PPO. Gamma not equal to 0, that means this is a PPO PTX. I even don't know what the abbreviations stand for. But you can see that this is what they want to use. But you can see that on some unseen cases or some distribution it hasn't seen before, the PPO PTX can degrade very much a lot on some smaller size model. But for large model and on their instructed distribution, the proposed model does work better than the fundamental PPO. Yeah, this one I covered that. I discussed with one of my audience. This right now is definitely above 6 for me. If the highest score I can give is 7. But a year ago, this was below 5. They're talking about results on NLP dataset. This is something I think it's just a try to make the reviewers happy, I think, because you can see that the authors of InstructGPT of this paper has already shifted their focus from the close set targeted question, unrealistic scenario shifted from this, and they're trying to focusing on real world users. They're trying to focusing on that, and this is why they hire human laborers to do these things. So I would say even their model doesn't work as good as the other proposed method on the public data set, I wouldn't care that much because suppose you already have a BMW X5. Why do you want to drive a Corolla, right? Yeah, just you can see this sentence is purely to make the reviewers happy. Yeah. Okay. Good. Paper accepted. Maybe this is also makes sense because with the update these numbers, so people if they are really interested in some specific public benchmark, they can compare that with the strategy. Okay, these are some two fun example. Especially this one I cannot understand because I think it's French, Greek or French. The first one is other language. It doesn't say which language it is. I don't understand this, so I skip this. Is it Spanish or French? But this one I can understand. They're trying to say what's the purpose of the list C in the code below. And you can pause the video and read the code by yourself. And the InstructGPT completion, well, they get something meaningful. But sorry being cynical here, but I'm not really understanding whether it's really understanding the code, because if you look at the function name, it says a binomial coefficient, right? And so the model starts to say, okay, it tries to use to calculate this. But I mean, what if you just name the function as f and nr? Other than this, what would the GPT say? If you're interested, you can just copy these things into your ChatGPT API and see what it says. But definitely, I think current ChatGPT wasn't doing very well on the factual questions. So this is why they're saying that it still makes simple mistakes. Yeah. For the discussion, I think this is fairly straightforward. I think I covered all of these. The only thing I didn't quite get it was the third sentence. But they were able to mitigate most of the performance degradation introduced by our fine tuning. It's not they mitigate by fine tuning. They said they mitigate something introduced by the fine tuning. But how? I didn't find anything in the paper. Probably I didn't read it carefully. Yeah, this is something that confused me. And also, this one is interesting. They're suggesting that so in the previously, if you want to train a task-specific model, you first have to train a larger language model. In their case, to train 175 billion parameter GPT-3, they need 3,640 petaflops per day. But if you're just trying to get a 175 billion SFT model, which is not as good as their PPO model, but it's still good enough, I think, to play with. It's way better than the GPT-3 or GPT-3 prompt. It only costs you about 5 petaflops. This is almost 800 times reduction in computational cost. Suppose right now, before that, they use 800 V. Suppose previously they use 800 V100 to train their model, but right now you just need just one V100 computational power. But definitely you won't be able to stuff the model in just a one V100 model. But just the computational cost is way smaller. And if you want to use the best model, 170 billion PPO-PTX model, you would reduce the computational cost still by 60 times, which is still a lot. It's 2 magnitude. But let me warn you, you still won't be able to train your own ChatGPT right now because it takes lots of GPU cards. My estimation is that you at least need to have hundreds of V100, and those V100 has to be installed in the HPC style. I'm not an expert on this, but I know it needs at least hundreds of V100, maybe thousands of. Yeah, and also this is very important or interesting. They're asking themselves, who are we aligning to? I think I would say to whom we are aligning to is better. They're saying that definitely. I think what they want to say is that their model might be biased. It's biased or aligned to, first of all, their trained laborers, because the laborer provides data. The second thing is they themselves, the authors themselves, because they designed the whole experiment and the algorithm, the model. When the training would stop, everything, they control this. They're controllers. I think they also give instructions to the laborers, okay, or select which laborers would be selected to do the work. And the third thing is definitely they're biased or aligned to their customers, but definitely doesn't represent all of the customers, because at the time they write the paper, only invited people can play with their API. Okay, I think this is very important. So one path forward could be to train models that can be conditioned on the preference of certain groups, or that be easily fine-tuned or prompted to be represent different groups. So you can see that, I think also they mentioned that in their note. So the purpose of this paper is not to train a general tool or general purpose machine learning model. I think this is not correct to laugh at ChatGPT when it failed on some tasks, because definitely you can imagine that ChatGPT was optimized or aligned with their own customers and their own business model, their own business needs. It's shared with you guys doesn't mean that they have to follow your needs. It's they want something that align with your company needs. And also, I think imagine that there is a nonprofit group. They can also train their own version of ChatGPT to address their concerns, their own concerns. You can see that maybe in the future we could have ChatGPT for different group, different interest groups. Yes, I will stop here. I don't know how you think about my presentation. I wish you like it. Please subscribe to our channel. You get the latest updates. And thanks.